All right, here we go. I was watching Dick Cavett the other day, and he had Orson Welles on, and they were asking him about how when he made Citizen Kane, he did all this new age stuff with camera work that no one ever did before. And Dick Cavett asked Orson Welles, how'd you know it was going to work? And Orson Welles replied, he didn't know it was going to work. And it was only through sheer ignorance that he even tried this stuff. Had he known what he was doing, he probably wouldn't have tried that stuff. So in that regard, that's what got me into I'm sheer ignorance going into this, because I really don't know anything about electricity. The only thing I ever really knew about it was it's very useful and it's dangerous. But anyway, a bunch of years ago, about 2008, 2009, I got on the free energy kick, looking on online and stuff, and obviously I didn't get very far, but it was always stuck in my mind. And one day I had, I guess you call it a vision, and I actually asked myself, why am I seeing that? And oddly enough, I got a reply, and it told me you can use that to make energy. And what I saw was a whirlpool, the one up at Niagara Falls. Just popped into my head. So that got me thinking, and it took me about a year or so to come up with my final design, because I was going through all kinds of different things. But I did a bunch of research on, now water, you got to remember that water is, it's one of the craziest substances known to man. It's the only substance we know that it expands when it's frozen and contracts when it's heated. Every other substance does the exact opposite of that. And water, it moves mountains, does everything. It's the basis of life, along with carbon. Anyway, now when you hit water really fast, it's like concrete. And it doesn't even have to be, it could be the water moving fast. Like when a surfer is surfing and he wipes out, and he's under that tunnel, and his surfboard goes that way, and he goes tumbling. You're like, oh, ouch! That had to hurt, because it's like being in a cement mixer, I imagine. So water, it's almost like when it's moving fast enough, it's as solid as concrete. And there's this other weird thing about water. Let's say you have a river and you want to set up a water mill. Now, if you got a part of the river that's moving at 5 miles an hour and another one that's moving at 20 miles an hour, you don't get 4 times the energy at the 20 mile an hour spot. You actually get what would that be? You get a threefold if it's moving 4 times faster, hold on a second here, 4-fold faster, the kinetic energy increases by a factor of 16. That's crazy. So yeah, if your speed of your water, if the increase in speed is 2-fold, your kinetic energy will increase by a factor of 4. If the increase in speed is 3-fold, the increase in kinetic energy will be... Anyway, I'm screwing this up like crazy. Hold on. For a 2-fold increase of speed, the kinetic energy will increase by a factor of 4. For a 3-fold increase in speed, the kinetic energy will increase by a factor of 9. And by a 4-fold increase in speed, the kinetic energy will increase by a factor of 16. And so that's just kind of odd. So anyway, I was thinking about whirlpools when I started. I didn't even know any of this. It's called kinetic, there's a math thing here. Kinetic energy equals 0.5 mass velocity squared. I don't even know if that's multiply. I don't even know how this stuff works. That's how ignorant I am on this and uneducated. But I started, so I just had this idea that water, it's not free energy, but you can use it. It magnifies energy. There's energy magnification with water. It doesn't take a lot of energy to get water moving, but that water moving has a lot of kinetic energy in it. It's like when you start a whirlpool, that water, it wants to get down to that bottom. I'm talking a man-made, self-contained whirlpool, by the way, at this point. That water wants to get down back to the bottom of your container. And it's almost like it can't get out of its own way fast enough trying to get down there, and it can't. So it just keeps going faster and faster. And so what I did is I set up a garbage can, and I put 20 gallons of water in it, which hold on a second, sorry. I thought I had it written down here. Oh yeah, here it is. 20 gallons of water, weighs 167 pounds. So, yeah. So where am I going with this? Excuse me. So yeah, you get that water spinning, and so yeah, I put 20 gallons of water in it. Then I got this thing here. I made this. This is 1 meter circumference, and on the inside I put a piece of black tape, and I had this little ball, and then I took this little doohickey here, attached it to this cheap little drill that is 30 watts, 20 volts times 1.5 amps, 30 watts. And that made this little ball move around 1.25 meters per second. And just for the fun of it, I calculated at 1.1 meters, just because it did go over the 1 meter mark. And according to the calculations on a kinetic energy calculator online, Omni, that 167 pounds moving at 1.1 meters a second, that creates 45.82 joules of kinetic energy. And the funny thing is, the drill, I didn't even have it on the full power. I only had it running not even halfway, like a third of the way. So I wasn't even using the full 30 watts of this. And then another weird thing is, take into effect G-forces. When that water starts spinning and it opens up, it actually grows up inside and there's a big opening. So that means there's G-forces affecting that water. And when you have G-forces, what does that do? It increases your mass. Increased mass is a big part of kinetic energy. It almost like feeds on itself. The faster it goes, the more kinetic energy. The faster it goes, the more G-forces, which equals more mass, which equals more kinetic energy. And I know a lot of people will say, well, you know, Isaac Newton says this, that, and the other thing. Well, maybe Isaac Newton didn't know about, 1 horsepower and electric motors that can, move 6,000 RPM, because that's all this takes in a big tank of water. And you can move almost any size generator you want with a 1 horsepower motor. I guarantee it. I don't know how this can't work. It's very interesting. Just imagine a big tank with 10,000 gallons of water standing still that weighs 83,500 pounds. You get that water spinning fast enough, which you can with a 1 horsepower motor and the correct blades. You get that up to 5 Gs. That 10,000 gallons of water now has the mass of 417,500 pounds. Get it moving at 10 Gs. That same 10,000 gallons of water now weighs 835,000 pounds of mass. Because remember, there's two ways to measure mass: volume and weight. Some people don't see the weight part of this. They don't see how it increases the mass. I've shown this to people and they're like, it doesn't work like that. And I'm like, well, actually it does. 20 G's, that 10,000 gallons of water will now weigh 1,670,000 pounds. And all you got to do, here's my little drawing. Have the generator on top. Here's your little electric motor. There's a pass-through that allows you to go to these blades and spin them. And then that in turn will create your whirlpool and make your water go round and round, spinning your generator the whole time. And it'd be like any other generation. You get that generator up to speed, then you slowly bring a load on it. And the bigger the radius of your tub or of your container, let's say from 10 feet to 20 feet, the 20 feet one will need a slower speed to create a greater G-force. So, I mean, to me it seems, at this point, it seems pretty simple. I just don't know how it won't work. That's what I don't get, how it won't work. I'm going to keep this short for now. Visit me on Patreon, Innovator, I think it's called. I don't even remember. All right, thank you. Take care.